Right, my apologies for the wind noise. It's quite windy today. So we've got 2 lengths of 40 meters of Cat 5 cable. This is the far end going into the earth stake. And if we come along the path, blah-de-blah-de-blah. Here is our join at the middle, which is currently connected together because I want to do the initial test to confirm milliamps going through the line. And then here we are at the start. So I'll just chop this off. And today I'm using the green pear. And 2. Cool. Let's just go over here. It rained last night, so the paddock, the soil is quite moist. Do the clippy. And then, oh, I've broken that, haven't I? Right. Clip onto there and whoop. Contact and ensure that it is not to be touching anything. We don't want anything sort of leaking to earth via the grass or anything like that. Okay, so let's have a look at what we've got when we run it through as it is. So I'll start with 480 Hertz, and it (881 ohms), and we got 6 milliamps. Okay. Have I got my tape over the speaker nice and tight because I hate the noise that this thing makes. So 480 Hertz. I might actually need to take some of that. There we go. Okay. Turn that down. Sensitivity of 3%, okay. And if we are looking at detecting it from, say, about a foot above ground, okay, we'll use 8%. Now, if we check our signal of 3900, test, depth 30 centimeters, 0.1 milliamps, but 3961 is the signal level. Okay, now, halfway point will be approximately here.
Yeah, mate, you're right.
G'day! Signal 40... Okay, I'll go sensitivity level 10. Signal level 4000. .1 milliamps, 3,933 centimeters depth. Okay, carry on. Yep. Get that back down to 8. Okay, there's our halfway point. Carry on. About at the halfway point here. So 3,800. Depth of 35 centimeters, 0.1 milliamps. So it's not very good at reading the milliamps, this one. Okay. So now, let's try breaking these apart. Stay insulated. Have I got the tape in my pocket? No, it's back at the other end. So, looking at the green wire. And we will position these to be approximately 1 centimetre apart. Right, so going back to the start. Whatever we had before, it's now 0 milliamps. I'm going to put it up to high power. Do we get any increase? No, we don't. Let's try. Retesting it over 1 mega ohm of resistance. Injecting 35% 50%, 0 milliamps at 480 hertz. Well, I'm going to set it to 40% and go to the halfway point. Picking up a little bit, but that's even with the sensitivity turned up to 84%, so it's not even worth trying anything there. Interestingly, we're about 10 centimeters worth of signal coming off there. Okay. For fun, let's just go and test the other end, eh? Beyond that break. Nothing, not even touching it. Sorry, not even while touching it, we get nothing. So, that's test number 1. Let's then try test number 2. Silence that. Okay, so test number 2 is going to be, I'm not going to go and rejoin it, that's a lot more walking than I need to do, but we've got our gap in place now. So test number 2, 7.7 kilohertz. Mega ohm of resistance. Inject, it settles on 1%, but I'm going to turn it up to normally this I have set to sort of 10% because I'm only doing a single cable and I'm only going, say, 50 meters to 100 meters, just locating front yards and stuff. But let's try this 40%, 7.7 kilohertz at 7 milliamps. See what happens with that. So frequency 7.7 kilohertz, and that's coming off there real well. Let's turn it right down a bit. Okay. About 30 centimeters of accuracy. Oh, sorry, 30 centimeter signal sort of range where it can be detected, and 40 centimeters height, 5102 signal level, 0.1 milliamps. Just on that, the instruction manual actually talks about the signal level down here, not the milliamps is what you've got to use on this machine to test with. Okay, so got signal right up above it. Okay, as we go across, gets to the end and then it stops, and it's completely gone from the other side. If I turn up the power level, oh sorry, the sensitivity level, right up to 60%, you can kind of hear it picking up something there. But really, I think we're just picking up signal because we're in range of the end of the cable. If I was to pull that back, notice how it still goes up. So that's just signal coming off there, but it's not jumping onto this other cable. Yeah, far enough away. $2,300 signals unusable. So that's 7.7 kilohertz is a bit of a dud. What if we turn up the power? Yeah, let's do that. It's worth a shot. So 7 milliamps, we'll turn it up to say 60%. What does that give us? 13 milliamps. Okay. Interestingly, the cable's over there and I'm picking it up. So we're a metre above, signal 3208. That's much more usable. Let's push the button and find out what the reading is anyway. Zero milliamps, 3208, 0 centimeters of depth. So it's definitely not getting a depth reading. But now we go past the break and turn the sensitivity back up. We get something, but I think that's really still coming off that. So if I come across this way, it's getting stronger as I get closer to it, so it's just emanating through the air. It's not actually jumping onto the cable. I will admit that is now 5 centimeters apart. So my testing of individual sort of distances is probably not really going to work too well, I don't think. Because for an underground brake, we really need it to jump at least that distance, I think. So let's try. Next frequency will be 33 kilohertz. So frequency of 31 kilohertz. Okay, let's try that. 1 mega ohm. Injecting 0 milliamps. So let's turn it up. 2 milliamps, 5 milliamps. Let's go 30 milliamps. Oh, 30%, 9 milliamps. Let's try that. Okay, so frequency 31 kilohertz. definitely too strong for it, so that's cool. As we go along, we are following it. We're sort of near the end now, and the signal's definitely dropped off. I've turned up the sensitivity to get it to peak. 4,300 is the signal here. Let's just do a test and see what we get. Distance 4 meters. Well, that's only 1 or 2 feet. 0.3 milliamps. So yeah, not very helpful. But here we are at our jump, so let's bring those together to within about a centimetre of each other. Okay, we got a good signal there. Once we've passed the jump, he's gone. Coming back again. Literally within a metre, no, 2 metres. If the end it starts dying down, practically gone on the other side. If I adjust the sensitivity, turning it up, it's just not jumping across. So that's at 31 kilohertz. Let's try turning it up again and we'll see what happens. So 30% 9 milliamps, 50% 16 milliamps, so far away from it, and I'm still picking it up over here. G'day! And again, if it was jumping, that should be a solid signal going right through that cable. Instead, I think we're just picking up as we get closer to the break. We're just picking up the signal off the primary cable. So we'll do one more at 61 kilohertz. '61 automatic. wants to do 1%. Let's give it some juice. 21% still 0 milliamps. Interesting. 40% 3 milliamps. Let's go 50% 4 milliamps to start with. Frequency 61 kilohertz. Okay, sensitivity of 1%. We get it there. Okay. Yep. About the halfway mark. Signal 4500. Depth test. 2 meters. That's not 2 meters. Oh, 0.2 milliamps this time. Okay, well, it's on automatic this time, so let's just try seeing what it does on automatic mode. I think that's peak and null together on this one. 65 centimeters. Okay, that's getting close. No milliamps though. Okay. Yeah, we've gotten some distance from the end of the line, and the signal is rapidly dropping. Turn up the sensitivity, and at the end we get nothing. Turn the sensitivity right up. 50%. Nothing. If we're going back towards, yeah, okay. This is interesting. Sensitivity 25. Coming at the end. Okay. Rightio, so I can basically say that unearthed, the signal will not jump. But now, let's try earthing them. I think I'm going to have a fun time pulling the earth stakes out, so I'm going to just do 5 centimeters, I think, to start with anyway. And oh, you know what I should do? Not shock myself. That would be a cunt of a thing. Right. So be a while there. Let's check. people. That in there. So there's about 10 centimetres of ground contact there. Go back and turn it on. And we'll start again at 480 Hertz. Ooh, the sun coming out. All right, 480. 1.7 kilo ohm, 11 milliamps. I'll turn it up to 20%, 28 milliamps. So in theory this is going to be quite strong. Let's go to our halfway point. Okay. Cool. Depth. .91 centimeters. 1.4 milliamps. .38 centimeters, that's more accurate. 0.6 milliamps. Okay. G'day. Now let's have a listen to that there. Hello. So the signal's definitely died off a significant amount, but I can turn the sensitivity up. Depth is not accurate. Let's try that again on the hip. .41 centimeters. This thing's never been calibrated, so I'm not confident in the depth readings anyway. Now, halfway point. We have a jump. And up to here. It works. Sensitivity up to 40. least a metre high now. So that's good, that's at 480 Hertz. I am very happy with that actually. Well, actually, not really, because if I have to find a fibre cut, that's a bit annoying. That makes that somewhat more difficult to detect. I like the instant drop off actually. So I think you guys that are locating underground pipes would definitely be keen on a jump across, but for me, I'm trying to find a broken fibre cable and work out where the break is without having to go through the process of the OTDR, and yeah, that's quite cool. Well, for you guys. So let's try 7 kilohertz. Seven. 2 kilo ohms. Turn the power level up. So it's 17 milliamps. Frequency 7.7. Actually, I normally do everything in peak mode, so I'm going to try null mode here. See what that... no, it doesn't do depth in null mode. In peak mode, at 1% sensitivity, it's peaking. And we get no depth, no milliamps, 5,000 for a signal level. Okay. And we got peak for some distance away. Hello! Here we go again. We're jumping across. Halfway point. 10% sensitivity. Or 9%. Turn it down 3%. Yeah, we're no problems there. Actually, let's do a test. .3 milliamps. I'm not sure what this 227 number is here. Never actually got a proper instruction manual for this. I only got bits of it. I'll put it into auto mode. Yeah, it's worked out where it is, and I'll do a depth test. That's accurate, but no milliamps. Okay, right, we'll go back and we shall try, what was that, 7? We'll try 31 kilohertz next. 31 kilohertz and 2.2 kilo ohms, 2% it settles on, but we'll turn it up. %, 9 milliamps. So frequency 31. Go to the halfway point. About here. Peaking at 1% sensitivity. Depth. Zero milliamps, signal 5,000, 0 centimeters. So go past our brake. And here we go here. Signal 4,000. Give a bit of meter up. That's a sensitivity of 10%, so I'm 2%. Signal level probably needs to be turned down back there, but okay, so that's 31 kilohertz. And we'll try we'll do the 61 kilohertz. .3 kilo ohms, going up to 20% power. Oh, we're going to turn it really high. That's okay. Let's go up to 50%. We're only pushing 4 milliamps though. Frequency 61 kilohertz. .1% sensitivity, we're peaking it too high. But if we go past our brake, and turn our sensitivity up to 10%. Definitely got that power level too high, but the signal is jumping, so that does mean I can turn it down and still still detect it. So actually one other thing that I wanted to test, but I need the snippers for, so I'll go back and grab those. Actually, number one, bad ground. Let's try that there. Actually no, let's bring it. That's probably what you Americans would probably call a foot. Let's try that. Hammer in there, stake, and change it back to manual, 10%. We're still going. Not as good. But if I turn it up to 20% sensitivity, we can definitely still get a locate there. That's impressive. Oh, and in that case, I was going to cut the cable, but maybe I'll just try pulling the stake out instead. Very much reduced signal, so that stake is definitely having an effect. If I pick that up and touch it though, yeah, that makes a change. Just rip that out there, leave that in such a position where it's not earthed, and 20% signal, we get signal on there, but that's pretty, oh sorry, 20% sensitivity, we get signal on there, but by the time we lift it a foot, it's gone. So, yeah, that's pretty telling. Okay, and I guess that concludes the day's presentation.